Japan just recorded a major earthquake off its northeastern coast. Tsunami warnings went out across 7 prefectures. Tens of thousands of people were ordered to evacuate immediately. And before the waves even arrived, the Japanese government issued something it almost never issues, a formal warning that a stronger earthquake would. That warning is still in effect. And there is a detail buried in this story that almost nobody is covering. One that affects not just Japan, but every coastline in the United States that depends on early tsunami warning to have any chance of survival. Drop a comment right now and tell me where you live, coast, inland, or somewhere in between, because by the end of this video you are going to understand exactly why what just happened in Japan is not just Japan's problem. If you have not subscribed yet, do it now because we track exactly this kind of risk every single week. Here is what happened. A magnitude in the Pacific Ocean off Iwate Prefecture. The Japan Meteorological Agency immediately issued a tsunami warning for waves up to 3 meters, nearly 10 feet, across the northeastern coastline. Buildings shook as far south as Tokyo, hundreds of kilometers from the epicenter. Residents in coastal areas were told to evacuate immediately, to move to high ground, and to stay there. The warning said tsunami waves would hit repeatedly. It said not to leave safe ground until the warning was lifted. The waves that arrived were smaller than the warning suggested. The highest recorded was 80 centimeters at Kuji Port in Iwate. The 3-meter warning was eventually revised down to an advisory, then lifted. No deaths were reported. By the standard of Japan's seismic history, this was, relatively speaking, a manageable event. But here is what happened next, and this is the part that should get your attention. After the earthquake, the Japanese government issued a formal notification of heightened megaquake risk. Residents across 182 towns and 7 prefectures were told to confirm their evacuation routes and shelters, because authorities had determined that the probability of a larger earthquake, a significantly larger earthquake, had increased in the days following the 7.4. This is not a routine statement in Japan. Japan does not issue megaquake advisories casually. The last time the Japan Meteorological Agency issued a megaquake advisory was in 2024, after a different significant quake along the Nankai Trough. That advisory triggered panic buying of emergency supplies across the country. Hotels along the coast reported mass cancellations. The economic ripple from a single advisory ran into the hundreds of millions of dollars. Japan takes these warnings seriously because Japan has the most painful reason on Earth to take them seriously. On March 11, 2011, a magnitude 9.0 earthquake struck off the northeastern coast of Japan, the same general region where this earthquake just occurred. The tsunami it generated reached 40 meters in some locations, killed nearly 16,000 people. It triggered a nuclear meltdown at Fukushima Daiichi that contaminated a region the size of Connecticut and forced the permanent displacement of over 100,000 people. The total cost of that single disaster exceeded $200 billion. It remains one of the most expensive natural disasters in human history. The fault system that produced the 2011 Tohoku earthquake has not finished moving. The sequence of earthquakes Japan has been experiencing in this region, including the 7.4 that triggered this week's warnings, is occurring on and near the same fault zone. Japan's scientists are watching it closely. The megaquake advisory is not alarmism. It is the honest output of the world's most sophisticated seismic monitor network, operated by a country that has more experience with catastrophic earthquakes than almost any other on Earth. But the Tohoku fault is not the only thing Japanese scientists are watching right now. And this is where the story becomes genuinely terrifying. Japan's government has separately been tracking a fault called the Nankai Trough, an 800-kilometer undersea trench that runs along Japan's Pacific coast from the Kii Peninsula in the south to the island of Shikoku and beyond. The Philippine Sea Plate is slowly sliding beneath the continental plate Japan sits on, loading stress along that boundary. Scientists have estimated that a major Nankai Trough earthquake occurs roughly every 100 to 150 years. The last one was in 1946, which means the clock, by historical standards, is already past its expected interval. The Japanese government's own projections for a full Nankai Trough rupture are staggering. Up to 298,000 people killed. Up to $2 trillion in economic damage. Tsunami waves reaching populated coastal areas within minutes, not hours, of the rupture, because the fault sits so close to shore. In 2024, after a different earthquake triggered the country's first megaquake advisory in years, the panic response was immediate and nationwide. Rice disappeared from store shelves. Coastal hotels emptied overnight. The government had to hold press conferences urging calm, while simultaneously telling residents to check their evacuation plans. That advisory was for the Nankai Trough specifically. It was lifted after a week. The risk it was warning about has not gone away. Japan is, right now, managing elevated risk on 2 separate fault systems simultaneously. The Tohoku region, where the 2011 disaster occurred, is still active, and the Nankai Trough, which has its own documented history of catastrophic ruptures, is overdue by historical standards. The earthquake this week added a formal government assessment of elevated near-term megaquake risk on top of an already elevated baseline. When the earthquake struck off Japan, the U.S. National Tsunami Warning Center activated its monitoring protocols. The Pacific-wide tsunami warning network that protects Hawaii, Alaska, the West Coast, and U.S. territories in the Pacific depends on a global network of seismic stations and deep ocean buoys. These systems detect earthquakes and the pressure waves of tsunamis before they reach coastlines, giving emergency managers the minutes they need to issue warnings and begin evacuations. That network is in trouble. 9 seismic stations in Alaska are set to go dark this summer. Budget and staffing cuts to the agencies responsible for maintaining the warning infrastructure have left forecasters without critical data points used to assess tsunami risk across the entire Pacific. These are not redundant stations. They are primary sensors that cover some of the most seismically active and tsunami-prone territory on Earth. When they go dark, the models that calculate the size and trajectory of a tsunami lose input. The calculations become less precise, the warnings become less certain, and the time available to evacuate, already measured in minutes in some coastal areas, gets compressed further. The irony is difficult to overstate. Japan just triggered a Pacific-wide tsunami monitoring event. The Japanese government has formally warned its citizens of heightened megaquake risk on a fault that last produced a magnitude 9.0 earthquake and a nuclear disaster. And at the same moment, the United States is shutting down the sensors that would be the first to detect the tsunami if that fault moves again. To understand why this matters so much for American coastlines specifically, you need to understand the physics of Pacific tsunamis. A tsunami generated by a major subduction zone earthquake off Japan travels across the Pacific at roughly 800 kilometers per hour. At that speed, it covers the approximately 7,000 kilometers from Japan's coast to Hawaii in about 8 hours. It covers the approximately 9,000 kilometers to the U.S. West Coast in roughly 10 to 12 hours. Those numbers sound like a lot of warning time, and in theory they are. But the warning system only works if the sensors detect the event quickly enough, accurately enough, and with enough confidence to issue an authoritative alert. A false alarm can be as damaging as no alarm. After 2 or 3 false alarms, populations stop evacuating. And if the sensors that feed the warning models are missing, the models produce less reliable outputs, which means emergency managers face a harder decision about when to issue an order that could move millions of people. After the 2011 Tohoku earthquake, Japan and the United States invested heavily in improving the Pacific Tsunami Warning Network. DART buoys, deep ocean pressure sensors anchored to the seafloor, were added across the Pacific Basin. Seismic networks were expanded. The system worked during the 2011 event, giving Hawaii roughly 8 hours of warning before the waves arrived. Hilo Bay in Hawaii recorded waves of nearly 3 meters. Crescent City in California, which has the geometric misfortune of a bay shape that concentrates incoming energy, saw waves that caused significant damage. Those improvements are being partially reversed now. Not because the risk has decreased, because the funding has. Here is what you actually need to know right now, whether you live on the West Coast, in Hawaii, or anywhere within reach of a Pacific tsunami. The Japanese fault system that produced the 2011 disaster is still active. The earthquake this week was not a random event. It was the latest in a pattern of seismic activity along the same tectonic boundary that has been producing significant earthquakes for years. The Japanese government's own scientists have formally elevated the megaquake risk assessment in the wake of this week's event. That assessment covers a fault that, when it last fully ruptured, generated one of the largest tsunamis ever recorded in the modern era. And the warning network that would protect American coastlines from a repeat event is operating with fewer sensors than it had last year, fewer sensors than it is supposed to have, and fewer sensors than its own designers said were necessary to provide reliable coverage of the Pacific Basin. The earthquake that just hit Japan could have been larger. The one that comes next could be. The system designed to warn you when it is has a hole in it right now, in exactly the region where that warning matters most. If you live anywhere on the Pacific coast of the United States, in Hawaii, or in any U.S. territory in the Pacific, this is not abstract information. Know your evacuation zone. Know your route to high ground. Know that the time between a warning and a wave arriving at your coastline can be measured in minutes for near-source events, and that the system warning you is operating now with less redundancy than it was designed to have. Let me be specific about what that means for each part of the American coast that would be in the path of a Pacific tsunami. Hawaii is the most exposed American territory in the Pacific. It sits roughly in the middle of the ocean, equidistant from Japan and the U.S. mainland, and it has been struck by Pacific tsunamis more times than any other U.S. state. The 1960 Chilean earthquake generated a tsunami that killed 61 people in Hilo. The 1964 Alaskan earthquake sent waves that killed 4 people in Crescent City, California. The 2011 Tohoku tsunami arrived in Hawaii with enough force to cause widespread damage in harbors and coastal areas across multiple islands, even after hours of warning time. Hawaii has an extensive public alert system: sirens, emergency broadcasts, digital alerts. But sirens only help if the warning comes early enough and loudly enough. If the sensor network feeding the warning models is operating with gaps, the margin for error in the initial assessment shrinks. An earthquake that is initially assessed as a magnitude 7.8 but is actually a magnitude 8.5 produces a dramatically different tsunami. If the sensors that would catch that discrepancy quickly are offline, the first warning may underestimate the threat, and the revised warning may come too late for some communities. Crescent City, California, at the northern end of the state near the Oregon border, is the community in the continental United States most historically affected by Pacific tsunamis. Its bay geometry concentrates incoming energy in a way that amplifies waves arriving from distant sources. The 1964 Alaska tsunami killed 11 people there. The 2011 Japan tsunami caused millions of dollars in harbor damage there, despite arriving with over 9 hours of warning. Crescent City